Wave optics. Wave optics. That is optics. Optics, you know, similar to that lens. So wave optic means similar to that. How the optics behaving due to wave. So what will happen when wave is passed through the optics or lens? So some waves are passed to the lens. What will happen to it? So that only we are going to see. So before going this section, I want to say that one small thing. You know, right? When you visited lake, did you visit lake or ponds and throw a stone like that? Throw a stone to the lake. Okay, it will scatter. How the water will scatter? How the water will flow? Once you throw this, you cannot throw you have to throw in the not vertically. If you throw vertically, something like horizontally, if you throw horizontally, the rock will get into the water. Not like that. You have to throw slantingly, which is in the vertical direction, not in the horizontal direction. If you throw like that, what will happen? Will scatter like that. First it will steep into one place, another place. Some 3 places there, then if 4th place it will get into the sink into the water. So this is a small game they used to play in the childhood. Somebody did you ever play it? Did you ever play it?
Yes, sir.
Did you ever play it? So when you throw vertically something like that, the what will happen? Water wave will
Scatter.
something like scatter you see. So you can see something like wave-like structure of the water you can observe on the first one. In the second, wave-like structure or ring-like structure.
Yes, sir.
Some observation you made. Did you observe everybody?
Yes, sir.
All three girls observed or?
Observed, sir.
Yeah, you observed it. So that's a normal everybody used to play. Something like the scattering horizontal. Then the second thing also you can see it's another set of rings. In the second set, normally you will get 2 or 3, not more than that. 4th one, beyond 3, 4th one it will sink into the water. So that was over. So 2 or 3 you will get, and the 2 or 3 you will see the ring-like structure of the water. Many rings of the structure will, many ring of the structure will, once the stone where the exact position where is getting, from there you can see the ring of the structure of the things like that. Something like that you have seen, right? So this is what this is some game, something game playing, something game we can keep. Okay, so this was started. This was the initial idea of that Huygens. So he only proposed it, the Huygens principle. From this only the Huygens principle came and he proposed it. So how this yeah, so when a small drop of Huygens principle, first one is Huygens principle. Huygens, Huygen, Huygen, Eugene. No, it's Eugene. Huygen, Huygen principle. So when a small drop of stone, a small stone on a clay was dropped on a, when we drop a small stone on a pool of water, when a small stone was dropped on a pool of water, on the pool of water, wave will spread from the point of impact. Wave will spread from the point of impact. Wave will spread from the point of impact. Wave will spread from the point of impact.
Point of?
Impact. Impact means what? Point of impact means the
Touching the-
stone touching that water surface. That is the point of impact. So when we drop a small stone on the pool of water, a wave spread out from the point of impact. Every point on the surface starts oscillating with time. Every point on the line, every point on the surface, every point on the surface starts oscillating with time. Every point on the surface starts oscillating with the time. Every point on the surface starts oscillating with time. This shows the circular rings. This shows the many circular rings. This shows many circular rings.
Circular.
So all point on circle, all point on the circle, on such circle, all points on the circle, all the point on the circle, all the point on the circle, all the point on the circle will oscillate at this, all oscillate with the same frequency, or oscillate with the same frequency.
The same?
Or oscillate with the same frequency. All points on the circle will oscillate with the same frequencies. So this is which since they are oscillating in the same phase, since they are oscillating in the same phase, since they are oscillating at the same phase, they are called wavefront. They are called wavefront. Wavefront. Since wave front, F-O-R-N-T, front. Since they are oscillate in the same phase, they oscillate in the same phase, is called wave front. Since they oscillate, all the points are oscillate in the same phase, all the waves will move with same velocity. All the waves will move with same velocity.
The oscillating in the same phase?
Since they are oscillate with the same frequency, they move with same velocity. All the waves will move with same velocity. Because they are oscillating at the same phase, they are oscillating at the same phase. So they oscillate, they will move with the same, all the waves will move with the same velocity.
Since they oscillate with the same frequency,
They will move with the same velocity. Nu is equal to C by lambda. C by lambda. Yeah, nu is equal to C by lambda. Yeah. Okay? Okay? You are done. And this wavefront is called a surface of constant phase. This wavefront is called surface of constant phase. This wavefront is called surface of constant phase.
Surface of constant phase.
This wavefront is called surface of constant phase. This wavefront is called surface of constant phase. So according to Eugene principle, no, that was over. You've taken, no? Just repeat what I told.
Wavefront is called
Fuller.
When we drop a small stone on the pool of water, the wave will spread from the point of impact. Every point on the surface starts oscillating with time. This shows many circular rings. All points on the surface will oscillate with same frequency. Since they are oscillating in same phase, hence they are called wavefront. Oscillating in same frequency, so they move with same velocity. Mu equal to c by lambda. Wavefront is called surface of constant
Correct.
phase.
Got it. And hence the Eugene principle is defined as Eugene principle. Hence the Eugene principle is defined as so each point of the wavefront is each point in the wavefront okay. Each point of the wavefront is the source of secondary disturbance. Each point of the wavefront is the source of secondary disturbance.
Secondary,
Each point of the wavefront is the source of secondary disturbance. And wavelength emanating from this point spread out in wavelength emanating from this point spread out in all direction. Wavelet emanating from this point spread out in all the direction with the speed of light, with the speed of wave. Wavelet emanating from these points, spread out in all the direction with the speed of wave.
direction,
Wavelet emanating from this point spread out in all direction with the speed of wave. And this wavelet emanating from the wavefront, this wavelet emanating from the wavefront emanating from the wavefront, this wavelet emanating from the wavefront are usually referred as a secondary wavelet. Are usually referred as a secondary wavelet. Wavelet. And if we draw a common tangent to all the sphere, if we draw a common tangent to all the spheres, tangent how you draw, no, you know, right? If we draw the common tangent, if you draw the common tangent to the spheres, if you draw the common tangent to the spheres, we obtain a new position of wavelet of we obtain a new position of wavefront. We obtain a new position of the wavefront. We obtain a new position of the wavefront. Refraction now. Refraction of the plane surface and refraction of a plane surface and refraction at the rare surface. Plane surface and rarer surface. Rarer means R-A-R-E-R, rarer surface. Okay?
Sir, here lambda represent wavelengths.
New C is constant. C is constant. for plane surface nu1 by lambda 1, nu2 by lambda 2. What is nu1? Medium 1. 2. Lambda 1 is wavelength in medium 1, wavelength in medium 2. This one is sin IC is equal to n2 in rare and medium, sin IC is equal to n2 by n1. IC is nothing but critical angle. Critical angle. Then n2 by n1 is 2 medium. Medium 1 and medium 2. Huh? Wavelength in which one?
Critical angle
Sin IC. In rare and medium. Well, we've already talked no, in plane surface and in rare and medium. Okay? Doppler effect. Okay? No, did you take in this?
Yes, sir.
You taken this?
Yes, sir.
Doppler effect. Doppler effect. Doppler effect. D-O-P-P-L-E-R. Doppler effect. The time taken between the arrival of two successive wavefront, the time taken between the arrival of two successive wavefront, the time taken between the arrival of two successive wavefront time taken between the arrival of two successive wavefront is longer at the observer than at the source. Is longer at the observer than at the source. It's longer at the observer than at the source. Thus, when the source moves from the observer, the frequency. So when the source is moved from the observer, the frequency as measured by the source will be small. when the source is moved from the observer, then the frequency as measured by the source will be smaller. Will be smaller. When the source is moved from the observer, the frequency measured by the source will be smaller. The frequency observed by the frequency measured by the source will be smaller. Frequency measured by the source will be smaller. This is known as Doppler effect. This is known as Doppler effect. The change in frequency delta nu by V is equal to change in the frequency. No, this one is change in the frequency, this one is by frequency. The total is a fractional change in the frequency. Fractional change. Fractional change. Fractional change. And nu radial is component of source of velocity is a component of is the component of is the component of is the nu radial is the component of source velocity is a component of source velocity is the component of source velocity along line of joining is the component of source velocity is a component of source velocity along the line of joining the observer to the source. The line of joining the observer to the source related to the observer. Line of joining the observer to the source. The line of joining the observer to the source related to the observer. The observer to the source observer to the source relative to the observer. Observer to the source relative to the observer. So the nu radial is the component of source velocity, along the line joining the observer to the source related to the observer. Coherent and incoherent addition of wave. Coherent and incoherent addition of the wave. So that is the superposition of principle. The principle of superposition states that principle of superposition states that the particular point in the medium, at a particular point in the medium, the resultant displacement produced by the number of wave, the resultant displacement produced by the number of waves is the resultant displacement produced by number of waves is the vector sum of the displacement produced by each of the waves is the vector sum of the displacement produced by each of the waves. Is the vector sum of the displacements produced by the each waves. So what is the principle? The particular point in the medium, the resultant displacement produced by number of waves is the vector sum of the displacement produced by each of the waves. So intensity is equal to 4 into initial intensity and cos square 5 by 2. Phi is equal to 0, 2 pi, 4 pi. Then the maximum intensity will obtain with constructive interference. 0 is equal to plus 5, 3, 5, 5, 5 means 0 intensity is obtained with the destructive interference. This is total intensity. You can write IT, then you can write as IT. That is individual intensity. Individual intensity of the wave. So constructive interference means maximum intensity, destructive interference means zero intensity. What? So we have finished a lot of chapters, no?
Yes, sir.
How many pages you got?
Sir.
35 pages in the plus two itself. Influence of light wave. Influence of light wave. Influence of light wave. If two sodium lamps are illuminated with this two pinhole, if two sodium lamps illuminate two pinhole, if two sodium lamp illuminating in presence of two pinhole, illuminating in presence of two pinhole, we will observe inference fringes. We will observe inference fringes.
Observe inference.
Huh?
Fringes.
Two inference fringes. If you eliminate the two sodium lamps with two pinhole, we will observe the inference fringes. Okay? This is because light wave coming from S1 and S2 are derived from the same original source. This is because light coming from S1 and S2 are coming from the same light source. So it's coming from the same light source, S1 and S2. And two lights will travel in the same phase. Two light source, the light from the two source S1 and S2 will travel in the in phase. Okay? The two source of light, the source of light that coming from S1 and S2 will be traveling in phase.
Traveling?
Like in phase. Hence the fringes will be observed. Hence the fringes will be observed. So the expression of the fringe width means fringe width. So beta is equal to lambda d by d, where beta is the fringe width. Lambda is wavelength of the source. D is big D. Distance of the fringe from the point source. From the distance of the fringe from the source. D, it is D. Distance of the fringe from the source. Then D is distance of the fringe distance between the two fringe. Distance between the two fringe. Distance between the two fringe. Two fringe means no, S1 S2 is the source of the light. Fringe means that band. This is the center point. Okay, fringe 1, fringe 2, fringe 3, fringe 4, fringe 5. This is a fringe width, this one is a width. Okay, then this, okay, you can take F3 itself. From this distance, from the fringe to this distance is D. Okay, distance between the
F2 is
Huh?
F2 and F3 is
F1,
and F2 is
no, F1, F2, F3, F4, F5, all are fringes. In that one you can take, just F3 you take. Okay, width of the fringe means this distance. Width of the fringe is beta is equal to lambda by D. Okay, now what is D? D is the distance of the fringe from the point source, from the origin. From the origin, what is this distance? Fringe distance. Then D is distance between the two fringe, that is this distance. This is D. I think you didn't study anything in the school, I think. Everything what I am studying is I am teaching you everything. Step by step I am teaching you everything. No? And is teaching in the online class? Huh? Online, they didn't teach you in the online class. But was during Corona period that the online class was going, no?
only some of the classes
They teach you in the online class. That is that is not sufficient, no? So they skipped a lot of things, I think. So only they teach you something. So they skipped all.
Just where what is optics that.
That's all. Some definition they teach and that's all. They skipped it. That's all. Oh. Diffraction. Diffraction. the inference of the wave, the inference of the wave by which it is scattered in different angles. What I told you?
The inference of the wave by which it scattered in different angles.
It's called a diffraction. That means what? See, this wave is this wave is there. This is theta 1, and another one is there, which is theta 2. So the theta 1 and theta 2 is, what is the difference now? Angle. That angle is distance. Which will have a higher angle?
Theta 2.
Yeah, theta 2. Then theta 3 will have a higher angle. Then theta n will have a highest angle. So the highest angle here will be theta n greater than theta. So any angle here, theta n will be the highest compared to theta anything, any power 1 or 2 or 3, anything is there, they are least power because theta n will have the highest scattering angle. Okay, then theta is equal to lambda by a. What is a? No, lambda. What is lambda? Wavelength. Then what is theta? What is theta? Lambda is wavelength. A is the distance between the two waves. Distance between the any wave. This is not two wave, any wave. It could be 2, it could be 10, it could be 1000 also. Distance between the two waves. Okay?
Yes, sir.
So D minimum is the distance of the inference that it keep. So 1.22 lambda 2n, n is the refractive index, sin beta.
D minimum is the refractive index.
Yeah, no, D minimum.
2n.
D minimum, D mini is equal to 1.22 lambda divided by 2n sin beta.
Lens at the focus.
Angle separated by the lens at the focus of the microscope. At the focus of the microscope.
Please.
Next refers to polarization. 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 Okay? Natural light from sun is unpolarized. Natural light from the sun is polarization. Natural light from the sun is unpolarized. Natural light from the sun is unpolarized. Okay, that means unpolarized means what? It can travel in all the direction. It can travel in all the direction. It can travel in all the direction. Rapidly and randomly. So, it can travel rapidly and randomly. In a polarized transmits only in contrast.
Polarized?
No, in contrast, polarization. In contrast, polarization is a 1. In contrast, polarization is a 1. Polarization is a 1, by which only the polarized polarized light will travel only in one direction. Polarized light will travel only in one direction. So polarized light will travel in the one direction. That will corresponds to that corresponds to travel the light. That corresponds to travel the wave in the maximum and minimum. That helps to travel the wave. That helps to travel the wave in. That helps to travel the wave in maximum and minimum. I have seen maximum and minimum. With certain angle called Brewster angle. With certain angle called Brewster angle.
Which angle?
By certain angle called Brewster angle. Brewster. B-R-E-W-S-T-T-E-R. Brewster. B-R-E-W-S-T-E-R. B-R-E-W-S-T-E-R. Brewster's law. Okay. So what I told you?
In contrast polarization is one
No. In what is the starting? In
contrast.
in contrast. First one.
Natural light.
Huh?
Natural light from the sun is unpolarized.
Hmm.
In contrast polarization
Hmm.
is the one by which only polarized light will travel one direction.
In only one direction. Then
That helps to travel the wave maximum and minimum.
maxima and minima, not maximum and minimum. Maxima and minima.
Maxima.
Ma and minima. You didn't write in the plus two max. Max. Which group you are?
First group, sir.
First group max will be no. What is maxima and minima? First group max no.
Pure science.
Okay, fine.
Maximum value.
And minimum value. That's all. Maximum and minima. See, everything is connected. This is physics. Physics is connected to maths and chemistry is connected with physics. Everything is connected. Okay?
With certain angle is called Brewster angle.
Brewster's angle. BREWSTER. So IB is given by Brewster's angle. So sin IB by sin R is equal to sin IB by R. So R is replaced by sin pi by 2 minus IB. So sin pi by 2 by IB is equal to cos IB. So sin IB is equal to tan IB. And the tan IB is the Brewster's angle. Brewster's angle. Okay?
Please, sir.
Okay? Yeah. 5 minutes break.